Hi, welcome back to ARISTOTHINK, and now let's just start a new topic, okay? The topic we're going to see now is going to be a little bit more complicated, but it's not going to be the end of the world, I promise you that. Well, in the last set of videos we saw arithmetic progression, like 2, 4, 6, 8, 10. We just had to add something very simple or subtract something, and we call that the common difference. Why common difference? Because there is a difference, okay, being something positive or negative between a term and a subsequent term. And that was very easy, okay. Well, of course we saw that we could make it very complicated, but it was not, okay, let's face it. Now I'm going to present you something a little bit more different, and now things can get a little bit more complicated, but it's still not the end of the world, okay? Now, what you're going to see now is going to be called geometric. Well, it's going to be geometric sequence or geometric progression. Okay, you choose the way you prefer, okay? Progression or sequence. Okay, you just choose what is best for you. Now, what is all about that? Well, let's first define, of course, what are we talking about. And for that, I'm going to use this pen. So let's define what is a geometric progression. Well, it's going to be every sequence of real numbers except, and this is very important, except the zero. The zero cannot be in here, okay, is not welcome, except 0, where every next term, every next term is the, now another interesting word in here, let's put in blue, is the product. And why am I emphasizing the word product? Because it is a product, okay? Before we have like 2 plus 2, 4, 4 plus 2, 6, 6 plus 2, 8, 8 plus 2, 10. The common difference was a plus 2, a simple adding problem. Now we're going to see that to build the geometric sequence, we're going to have to multiply each term. So now it's going to be 2 times 2, 4. Then 4 times 2, 8. Then 8 times 2, 16. 16 times 2, your turn. 32. Good. Now, we have to laugh, of course. To have a class without laughing is very boring. Of course, everybody had teachers who, I don't know, hey, they just couldn't laugh. They just walk in into the class and left without even, we couldn't even see his teeth. Maybe he didn't have teeth, I don't know. But anyway, we have to make math fun, right? So, let's get back. Every sequence of real numbers except 0, okay, where every next, okay, term is going to be the product okay, by, let's continue, okay, by what's the product, okay, every next term, okay, is going to be the product of its predecessor by a constant. And that constant which we will call it the common ratio. Oh, let's just put, it's too thick. Oh, well, let's use this one. No, it's not going to, if I use this pen, it's not going to be able to fit in here. So it's going, the common ratio, which we call it q, small q. Remember the common difference in the arithmetic sequence, we call it d, okay, from difference. Now it's going to be q from ratio, okay. And what is a ratio? Ratio is, it usually means this. The ratio is like 5 to 4, 5 to 10. So a ratio is a number, it's a fraction, right? Like a number divided by another one. This is a ratio, okay. So a ratio involves like division, and division is nothing else than multiplication. So that is what we call this q in here, and that's why we call ratio. And well, now let's see two interesting things in here. The first star, let's make like here. Okay, so well, we are going to have two most broad way to distinguish geometric sequence. We can call it in two ways. I'm just trying to get difficult in here to find a term to define, okay. I'm not going to do that. Let's just say we can have finite sequences and infinite sequence. The finite sequence are going to be the ones that we just have a certain amount of terms, like 10 terms, 20 terms, maybe 1,000 terms. It doesn't matter. We are not saying how many terms you should have. We are saying that we know exactly how many terms, and this is going to be the finite. Let's color a little bit. This is going to be the finite sequences. Okay, and finite sequence, they're going to be like 2, 4, 8, 16, and that's it. Okay, can we have more? Yes, we can, but it must have a first term and a last term. Okay, and you have to know that. So this is a finite sequence. Well, what are another type that we might have? Well, we might have another one that's going to be an infinite sequence. Okay, sequences, right? Plural. Now we are not going to have the last term. That is the only thing. Let's make like this: half. I'm going to multiply by 3 now, okay? No, by 2. Let's multiply by 2. Or better, let's divide by 2. So our common ratio is going to be half 2. So half, then half times half is going to be 1/4. Then it's going to be 1/8. Yes. Now next one, 1/8 times half. What is it? 1/16. 1/16. And now is the difference. You see, we are going to have those 3 magical dots in here. They are going to represent, it goes all the way to what? If we're just making the denominator bigger and bigger, oh, I'm terribly sorry. I could not have written in here. So I'm going to take this one and put it down here. And I'm sorry, but I'll have to reduce a little bit. I'm terribly sorry. Okay, now you can see everything. I'm sorry. Okay, I made a dot in here. I should not. Can you see this dot? I should not write anything in this sequence, but as I start to lecture, I just forget about anything and I just focus on the topic. So that's infinite sequence in here. It's a very interesting one. Why is it interesting? Because the last term, which it's all the way to infinity there, but the last term, or the last terms, okay, they are going to be basically 0. Why? Because the bigger we make the denominator, the smaller the term gets. So that sequence is started in half and going all the way to 0. Okay, so this is the first part of this video, and now we're going to the next part. And now we're going to define something that's not going to be 1, 2, 3, 4, 5. It's not going to be anything new, but we have to define, okay? And now let's define what types of sequence we might have. In the same way we had in the arithmetic sequence, and the types are going to be those. Well, what are going to be the types? Well, we're going to have 4 types. We're going to have the growing sequence, then the decreasing sequence going down, then the constant sequence, always the same. The constant has common ratio 1, right? And now something new, because we have those. Okay, what is the growing sequence on the arithmetic sequence? Very easy, right? Okay, like 2, 4, 6, 8, 10, so on. Now, what is decreasing? Like in arithmetic, 20, 18, what? 16, 14, 12, go on. 12, 10, 8, and so on. The constant. Well, the constant for a geometric sequence, the Q is going to be 1. And for arithmetic sequence, the D, the common difference, is going to be 0. Okay, but we had those 3 in back there. Now we're going to have something new, the oscillating. And this one is new. And this one I would like, and this one, trust me, makes the entire sequence very beautiful, because we have some problems that if you have never made them before, you are going to get absolutely lost. So we're going to have those in here, this, and this. Okay, now let's just give a very simple example in here. Like growing, we could have maybe like this, like 1/8, then 1/4, then half, then 1, then 2. Have you seen what is going to be the common ratio in here? Think about it. Okay, of course, if you just look in here, it's very obvious, but try to think about this. It is just 2, right? Now, decreasing. Okay, the decreasing, well, it must be what? Negative? No. This negative, it's when we have arithmetic sequence. Now we have to work with fractions. Okay, it's going to have to reduce. Maybe we're going to have 160, 80, always half. Okay, multiply by half, 20, 10, and so on. Q is going to be like half now. Okay, but why? Because from here to here, just multiply by 2, right? Always multiply by 2. Always multiply by 2. And from here to here, always divide by 2. Can you see? 80 divided by 2, 40. 4 divided by 2, 20, and so on. The constants, I'm going to put in here, well, maybe 17. Q, it is just 1. Why? Because we just have to multiply times 1 every time to get the next term. And finally, we're going to have the oscillating, and this one is beautiful because we could have like 1, -1, 1, -1, 1. And if you say, okay, it's very obvious, very ridiculous, this one. No, it's not, because sometimes they just ask, for instance, what is going to be the sum, okay, or the product of those terms. And depending on the sequence, we might get in trouble if we're not focusing enough. So it could be this, or it could be like this, right? 2 minus 4, 8 minus 16. Can you guess what is going to be the next one? Try. I wait a little bit. Try. Look here. What do you think is going to be the next one? Well, if you said 32, you're right. Okay? Q in here is going to be just -1, and Q in here is going to be what? -2. So, you see, in this case, we have a growing type of sequence and also oscillating, okay? But actually we can't call it growing, because 2, then return, -4, decreasing, now increase, 8, okay, now decrease, -16. So it's not a growing, okay? We had to give a different name for it. Can you say it's growing? It's not growing, right? From 2 to -4 is decreasing. From -4 to 8 is increasing again. So we see we can't call growing this one, and neither decreasing. Well, those are the basic of geometric sequence, okay? I hope you have enjoyed it. This is only the beginning, and don't worry, it's going to get complicated much further, okay? So thank you very much, and see you in the next video. And of course, I'm kidding, right? Math is not supposed to give problem to anybody. The idea of math, it is just to make us realize how beautiful and how easy it is, and how comfortable we can be when we can rely, okay, in math. So sequences like that are very beautiful to make, and we're going to see that if we know what we're doing, math is not complicated. And if math it is complicated to you, it means that you haven't got yet a good teacher in it. I just hope I can be that teacher for you, okay? We just have several ways to teach, and I just hope the way I teach, it is going to be the best for you, okay? And one thing that some students ask, why do I make my videos like 10-15 minutes, and why don't I write everything and just like PowerPoint, just press and everything goes into place? Because I still believe that the best way to teach is when we write things, okay? Because when I'm writing, it's a little bit difficult to be quiet, but mostly when I'm writing, the student, it is also thinking, it is recording, okay? It is the time for us to take time and to think what it's being said, and so we just have that time to record things in our memory, okay? So I think it's important to write instead of just popping out everything at the same time. I think it helps us to memorize and give us and gives the student a break, so he can just breathe a little bit, so he can just be prepared for the next 10 seconds, and that goes up to the end. So thank you very much, and see you in the next video. Bye bye.